just put in presentation mode. Your guys are seeing.
Yeah,
Yes.
we can see it.
Yeah. So I will present the oil spill segmentation for a satellite imagery. And our team was made by Amanda Dash, me, Maria Paula Gracioto, Jose Garcia, Jalen Rose, and Sikar. And so I'll just fill your guys in and how the idea came up. I'm not sure if everyone knows about the oil spill incident we have in 2019, and it was a huge one that hit pretty much all over coast, the northeast and some of the southeast coast, and the logistics was terrible, pretty much because it's a huge site, and well, in Brazil, not everything is easy. But after that, the government created this project that calls Project Sisman, the oil monitoring system at sea, led by our National Institute of Spatial Research that Jose and I worked on to create this monitoring system to our Navy and our environmental agency, IBAMA. So that's how the idea came up for the Ocean Hack. So the main project idea was to create an automated process to identify a possible oil leak in a satellite image, cropping the area of interest, and then start some validations to see if it's oil or a lookalike. And the important observation is that it's not a classical AI work. We didn't want to use the classical neural process or stuff like that. It's just to optimize the creation of label datasets using Python scripts, and it's aimed to segment the SAR images with a huge size. So for now, we use just a single image. And for that, we create this roadmap to try to understand what we have to do and to help the team to understand and follow the steps. So I present what we really did because we couldn't make everything, of course. So the first step is to get the single label SAR image. So that's the one we try to process. It's a huge image, and the oil leak, it's really small. So that's the difficult for that. So after that, we try to do some patches. First, we set a threshold, and then we did the chunks to get easier. And here is the code for do the patches. So I just processed the level 500 here just to go faster. But the idea is to do like a parent, so 500 to 5 and 100 chunks size. So that will be get the histogram of the image and doing the links to get easier to find the the oil slick in the image, because in the huge image, it's really hard to see in the histogram where is the slick is. So the step 3 is the segment and the patch received on the step before, considering just the histogram first. So I create a new threshold with the range of the oil slick and try to make this mask, creating a new array segmentation with to make a mask with white and black only. And here is where everything crashed because I had to put together the histogram, the mask histogram with the X and Y coordinates to then create an image for the step 4, where we are create this visualization tool that we have the original image, just the mask, and then we can combine them together. And with that, we can select the interest segment by clicking on it, calculate and extract some the polygons and some statisticals that will help us to understand if it is oil or looks alike, like no chlorophyll or lack of wind, for example. This is the code to do that. Jose made for us, and this take the image and then make a new dimension because it's too big. So he not crop, but he just dimension, and then he asked what you want to do if this next image extract the mask and do some statistics with that, like the geometry mean, harmonic mean, median, and stuff like that. And then we want to do these statistics that we found in the literature. So one of that is the ideal you want to do. It's in the sorry, no, it's not pink, but in the pink one, have some good reference of what we have to do to understand better the segment. And that's what we aim to do, but we couldn't do now. But that's it.
Thank you. Do we have any questions? We have a couple of minutes for questions. Feel free to just unmute yourself and ask the question. Okay, thank you, Maria.
You're welcome.
We will now move on to the second presentation, marine species